In this video, we're going to be learning how to create an analytical model from this portal frame structure. If you are wondering how to go ahead and model this portal frame structure, check out the YouTube video in the link card above. Alright, let's go ahead and do it. So to create an analytical model from this portal frame structure, the first thing we're going to do is go over here to the Analyze tab. In the Analyze tab here, I'm going to click on Analytical Automation, and it's going to bring up a script for us to convert elements from either a physical model to an analytical model or an analytical model to a physical model. Since we already have the physical model, we're going to be picking the physical to analytical for buildings. To go ahead and use the script, I just go ahead and click on play. Once the script is open, you'll see we have a bunch of inputs and we have steps that we can follow. Now, ideally, you can go ahead and select all the elements and create the analytical elements or panels all at once. Or a proper workflow would be to go ahead and actually select some elements and create them one by one. So you make sure that all the analytical nodes and members are connected properly. Let's explore a proper workflow. So I'm going to come inside here and I'm going to first of all pick the rafters. I'll select one of the rafters, right click. I'll go ahead and click on select all instances visible in view. Once I've done that, I'm just going to come and click on this button here to isolate the elements that I have selected. I'm going to go ahead and click on select and then make a selection over the rafters. Once I've done that, I'm just going to go ahead and make sure that my tolerance value is set here to 0. I want to have the ability to adjust elements that don't connect to each other. That way I can control the geometry and plane at which my rafters are placed. Keep in mind that the analytical members would be modeled with respect to their neutral axis, that's along the center of the beams. I'm going to leave all the other values as the default, the update parameters, update geometry, and then I'm going to make sure that this here option to adjust analytical elements to nearest level is turned off. We have other settings as well for first group of elements to consider for adjustments, and you normally use that when you have two categories of elements selected. Let's go ahead and leave everything as default. I'm going to go ahead and click on run. And you can see that the analytical automation tool is complete. If you scroll down, you see the list of analytical members that were generated from their physical counterparts. And if you select any physical element in the project, you can now see it now has an highlighted association. Let's go ahead and open the analytical view. In the 3D views, I can come ahead and open up the analytical model, and you can see the analytical members. Let's come here into the view tab. I'm going to go ahead and tile the views together. I'm just going to orbit around. Just going to move this to the side a bit. There we go. If I select this rafter, for instance, you can see if I click on highlight association, it shows here the element that is highlighted or it is associated with. Likewise as well, if I select the analytical member and I click on highlight association, it shows the physical element that it is assigned to. You can also see the properties of the elements from here, such as the materials taken from the physical properties. You can also see the section type as well, and you have other information such as the cross-section rotation. Let's leave everything as it is. Now, I want to make sure that my rafters are connected properly. To do that, I'm just going to come back and switch here to tab view so we have more view range. Inside visibility graphics override under graphics in the properties pane, I'm going to click on edit. I'll come over here under analytical model categories and make sure that analytical nodes is turned on. I'll click on apply and OK. Now I want to make sure that the nodes that are connected are actually connected. If I move or pan or zoom into this region here, if I make a selection, I can see I have two nodes and they are unconnected when they are actually meant to be connected. To see that better, I can come to the visibility graphics, override, click on edit. Under filters, I'm just going to go ahead and add a rule. I'm going to go ahead and select here connected analytical nodes and then I'll click OK. For the lines, I'm going to go ahead and set this here. Let's set the line pattern here to solid. It doesn't really matter, but let's just change solid. And then I'm going to go ahead and set the color here to green. I'll click OK and I'll click apply. As you can see, we don't have any connected analytical nodes at the moment. Let's go ahead and add another rule for unconnected analytical nodes. I'll set this line here to solid as well, and I'll set the color here to red. If I click apply, you can now see the nodes that are not connected. We want to make sure that the two rafter members are connected properly. So let's see how we can fix that. So working in the analytical plane, you want to make sure that these two members are along the same plane. So I can walk around with my navigation cube first. I'll click on the right view. There we go. And make sure that they are falling on the same plane. I can turn off the thin lines as well to make sure that they are on the same plane. I can make a selection to be sure that I have two members in this plane. So once you've established that, you can go ahead and use the trim extents to make sure that they are connected. You can do this especially if you are using Revit versions 2025 above. So what we can do is we can come to the modify tab. I can click on the trim or extends to corners, click on this member, and now you can see they are connected properly. If you're using another version of Revit, there's a workaround for you. I'm going to switch here to the front view, and I'm going to zoom in till I see their intersection. So you see that the nodes intersection missed by a bit. I'm just going to go ahead and make a selection over the node points like this, and I can see I have a total of 6 nodes. I'm going to go ahead and use the move tool to drag or move them back to this point. Make sure that your constraints option is not turned on. So if I click here, I can move it all the way to this intersection. Now you can see that those nodes are connected. I'll make a selection over these nodes as well. I'll go ahead and click on move, and then I'll go and move it to this intersection. So we can see here that we had an issue with some of the elements moving again. So I'll just go ahead and make a selection over this again. And we can see those are 6 nodes. Then I'll move them till they intersect with the existing. There we go. Now if we make a selection of all the nodes, we should have a total of 6. I'm just going to orbit around so we can see exactly what we have. There we go. Before we continue, I want to make sure that the analytical members I've modeled for the rafter are along the neutral plane. So I can come into the 3D view, and over here you see this button for show analytical model. I'm going to switch here into the front view. I'll select one of the elements, or I can switch the view here from shaded with edges into wireframe to check if they are along the neutral plane, which they are. Alright, great. So I'll end the object isolation, and now I want to create analytical members for the columns. Okay, I'll select one of the columns for instance. I'll right click. I'll click on select all instances visible in view, and I'll isolate those elements as well. Then with the analytical automation tool again, just going to go ahead and scroll up, click on select, make a selection over the columns, leave all the other settings as default, and I'll go ahead and run. Alright, if I scroll down, you see the list of analytical elements that were created. If I go to the analytical model, you can now see the column elements are being modeled for the analytical members. Now we can clearly see here that the rafters and column are not connected. Let's see the reason for that. First of all, I'll switch over here to the front view. And to connect this rafter to this column here, I'll go ahead and select the node. Now I'll move it according to this red line here in this axis. So I'll click on that grip point and then just drag it in the straight direction until it intersects with this column. We can see even with that as well, that node is unconnected. Let me just go ahead and orbit by clicking on the edges of the view cube. You can see that it's still unconnected. Let's go ahead and check the reason for that. If I switch here to the right view and look very closely, we can see here that the columns and the beams don't exactly meet with each other. Alright, so what we need to do is we need to adjust either the rafters or the columns. Now the reason for this is possible that the elements do not align properly with each other. If I end or reset the isolation, there we go, just going to take it back, then just come and switch back here. It's possible that the elements are not properly aligned, but you don't need to worry about the physical elements. We can come back to the analytical and adjust them manually. I'm going to make a selection of all my rafter members like this, and I'm going to zoom in a bit. So to see it better, just make sure that your thin lines option is turned on like this, so that's where you'll be able to see the lines better or the members better. I'm going to make a selection again, and I'll just zoom in a lot, and then I'm going to click on the move tool. Now while moving, just make sure that your disjoint button is not turned on. If it is turned on, it's going to remove the association of the members from the physical counterparts. So I'll click on any of the nearest points, then I'll go ahead and move it to the column intersection. And you can see here that that column and beam are now connected to each other. So I'm just going to orbit around, hold down the shift and middle scroll button, and you can see they are connected. Let's do the same thing for all the other nodes. So I'll come back here and click on the front view, zoom in a bit. I'll make a selection of these nodes now. Since we have a line that we can move it along, then I'll click on move, then I'll click on this point and then drag it all the way to this intersection. Let's do the same thing as well in this direction. The first one, I'll select just a node here, then drag it with the red grip points all the way to this column, and you can see it's connected. Then make a selection of the nodes here. You can see we have a total of 5 of them apart from the one we just moved. I'll click on move, click, then drag them to meet this intersection. If we make a selection, we should have a total of 6 nodes on both sides. Now for the columns nodes, we're going to go ahead and make a selection of the nodes like this. I selected this one here. I'll hold down the control key and make a selection of this node. So we have a total of 12 nodes. I'll click on the move tool, click on these endpoints here, and then move them all the way to these points to make sure they're connected. So you can see here that the rafters as well have been adjusted. So what I'll do is I'll make a selection of them like this. The first one is here. Hold down the control key, make a selection of this. Then I'll go ahead and use my move tool to move them back to each other. There we go. Okay. Likewise as well, you can come to the 3D view and make sure that the elements still fall in within their respective plane. Now let's generate the braces. So I'll come back here and I want to click on select. Before I do that, I'm just going to select one of the braces, right click on it, and then I'll select all instances visible in view. You can see we have the same brace type for all of them, total of 48. I'll just come inside here and I'll isolate those elements. There we go. Then I'll make a selection of all those elements like this. Alright, so we have a total of 48 elements, and I'm just going to go ahead and click on run. Alright, so you can see the list of elements that were generated or members, and if I go to the analytical model, I want to make sure that all those elements are connected properly. So I'll orbit around. I can hold down the control or shift and middle scroll button, so orbit around, and we can see here that these braces here in this direction are connected well, but we have an issue with the braces on the roof not connected properly. So let's go ahead and adjust that manually. To adjust the roof brace, what I'll do is I'll switch over here to the front view to see the plane that they are currently on, and we can clearly see here they are not falling on the same plane with the rafter. Even though their geometric positions are not the same, for the purpose of analytical modeling, they have to fall on the same plane. So what I'll do is I'll make a selection of all those members. I'll select them like this, hold down the control key, select this. So I have a total of 12 members in this direction. Then I'll come here, hold down the control key, select these members here, then select these members here as well. I can orbit around and make sure that I just have the brace element selected. Then I'll switch back here into the front or back view. Then I'll just go over here and use my move tool. I'll click on this point, and I want to make sure that my disjoint button is not turned off, or else it will remove the association. So I'll turn off my disjoint button. I'll come here and click on any line or any point along the brace, click, and then move it straight downward to meet with my rafters. There we go. Now we can go ahead and adjust the points where they are not meeting. So to do that, I'll switch here back to the front view. I'll zoom in a bit. I'll make a selection over the end nodes, and we have a total of 6. I'll come here and click on move, and I'll move them over here to this point. I'll do the same thing as well in the other direction. Make a selection over these nodes like this, go over here and click on move, then move them all the way to this endpoint. And now we can see all our nodes are connected properly for the braces. Let's model the analytical members for the Purlins and the Girts. So I'll switch back here to the 3D view. I'll end the isolation or reset the isolation. There we go. I'll select the Purlin elements and the Girts elements. So I'll right click on this and I'll click on select all instances visible in the view. There we go. All right. Then I'll isolate those elements again. As you can see. And what I'll do now is that I'll come all the way back to my Analytical Automation tool. I'll click on select, make a selection over all the elements. I have a total of 160, by the way. Then I want to come to the analytical model so I see how it generates up immediately. So I'll go ahead and click on run. And now you can see here that we've generated the members for our pulling and our braces. But if you look very closely, you see where that we have some issues. So for instance, where we should expect these two what they call Girts members to meet, we have them not connected to each other. All right, so let's see how we can go ahead and fix this, because for the sake of modeling, we want them to be connected to each other so they sit directly on this column. So how can we fix that? What we can do is that we can come back here into the Analytical Automation tool. We still have those elements selected, and we can give it a small tolerance value so the elements are connected, or it identifies elements whose nodes are close to each other and adjust them. So what I'll do is I'll give a small offset of, or rather tolerance value of about 0.1 or 2. Let's use 0.2. And I'll go ahead and run this again. Now it's important that we have the update parameters and update geometry options turned on for this to work. If not, it will go ahead and create a duplicate of those analytical members in place. So I'll click on run now. And you can see now that the nodes are connected to each other. If I zoom in a bit and I select it, we see that those nodes are now connected. All right, let's switch over here to the front view. We can see here that our gates don't fall directly on the columns. So let's go ahead and adjust that. What I'll do is that I'll go over here and make a selection over my Girts elements. There we go. And I'll go ahead and use the move tool. So I'll click on move. I'll make a selection from any of the endpoints and then move them to fall on my column. Once I've done that, I want to go ahead and switch to any of the views to make sure that they are currently or properly connected to the columns, as you can see. So just make sure that they are connected as such. I'll come over here and switch back here into this view, and I'll do that for the Girts in the other direction. So I'll make a selection like this. There we go. Then I'll come here and click on the move tool and then move them to fall on my column. Now we also want to make sure that the elements that are not connected, we go ahead and fix that. So we see a bunch of these elements are not connected properly. So I'll switch here to the left view. It's all about knowing which view you need to switch to make sure they fit. So we see here that they rarely, or rather they are just very close to touching the column, but they don't. So I'll make a selection over all those nodes just like that. So we're selecting the nodes here. And I'll zoom in a bit and then hold down the control key to select these nodes. There we go. I have a total of 14 of them. Then I'll come ahead and click on the move tool. Then I'll click on this node and then I'll go straight and make sure that it attaches itself to the column. There we go. All right. Now let's go ahead and adjust the purlins. If I go ahead and switch here to the front view, you can see the purlins do not rest directly on the rafters. So we want to go ahead and make sure that they rest directly on the rafters, and then later on we can create offset values in our design software. So I'm just going to make a selection over all those purlins here, making sure that I don't have a selection over any of my rafter elements. So I'll just hold down the control key and select those elements. There we go. Carefully select the elements. You want to make sure you are not selecting the rafter elements or their nodes. There we go. All right. So I'll just orbit around and make sure that none of the braces or rafter elements are selected. Then I'll switch back here into the front view. There we go. And then I'll go over here and click on the move tool. So just click on any of the nodes here and then make sure I move them straight down to attach themselves to the rafters. Let's orbit around. You can see now that they are properly connected. Just make a selection to make sure that you have one node in place where they intersect with the rafters. We can see here that because of an overhang here, the purlins don't lie directly on these rafters, and this may cause an issue, especially when you export it to another software, design software. It might act more or less like a cantilevered purlin, and that may not be the case. So this short distance here is very negligible, so we can adjust them here to sit directly on this rafter. So I'll go over here and switch here to the left view, and I will make a selection over the nodes like this. There we go. And I'll click on the move tool. Then I'll make sure I move them all the way to match with this. There we go. Then I'll do the same thing in this direction as well. Make a selection over the nodes. Click on the move tool. Click here. Then drag them to intersect. There we go. Now let's go ahead and take a look at a tricky one. We want to be sure that these purlins are sitting directly on the rafter. Likewise as well, the girts are sitting directly on the columns. So I'll switch over here to the top view, and I can see clearly, just going to zoom in, that they miss it by a bit. So let's go ahead and inspect the top. So this one is connected properly. This one here is not connected. If you zoom in a lot, it's not connected to the rafter intersection, and this is not connected, but this one here is. Okay, so what I'm going to do is I'm going to adjust this set. To adjust that set, I'm going to make a selection over all those nodes like this. There we go. Then I would remove the members. So I'll hold down the shift key and make a selection of all the members. I just want to have the node selected. There we go. Just going to zoom in, and then I don't want to have the rafters selected as well. So I'm just going to hold down the shift key and then remove the rafters. Hold down the shift key, move the rafters in between. There we go. And if you look very closely, these ones are connected. So I'll hold down the shift key and exclude this. We can also see that these nodes are connected properly, so we can exclude them. So hold down the shift key and exclude this. Exclude this as well. And this. And this. I'll do the same thing on the other side as well. There we go. So we only have the nodes. Just to be sure that we're only selecting the nodes. Okay, we still have this. We haven't this selected, so remove this. So to be sure we only have nodes, I'm going to click on filter and then make sure that the nodes are the only ones that are selected. So I'll click on apply and OK. We can orbit around as well to make sure it's just the nodes. There we go. I'll click on the top view again. I'll zoom in a lot to where I can see their intersection, and then I'll click on the move tool. Click on this intersection and then move them all the way to this point. Now let's go ahead and check for the girts. So I'll just switch here to look at the view on the elevation in 3D view, and we can see here for the girts that they are connected properly. You have to make sure you zoom in quite a lot to be sure that they are connected properly. There we go. Now you know you've done everything correctly when the analytical members still have their physical association. So let's go ahead and check. If I come back here into the 3D view, I'll reset so I can see all my physical elements again. Alright. So if I come back to the analytical model and I make a selection of over all my members and nodes, I'll come and click on filter, then turn off my analytical nodes, click on apply. And here I'll come and click on highlight association. When I'm in the 3D view, you can see that all of those analytical members are associated to physical counterparts. That's a good sign. Let's go ahead and add a finishing touch. We want to go ahead and add this structural columns here, this rectangular column footing. So I'll select one of them, I'll right click, I'll select all instances visible in view, and I'll just go ahead and isolate those elements. There we go. I'll come and click on select the columns just like that, and I'll change this value here back to 0. I don't want to adjust them, and I'll click on run. Let's go to the analytical model first before we click on run. So they are expected to connect to the bottom of this column here, as we see. So if we click on run, those unconnected nodes will now become connected nodes. There we go. Let's look at how we can make an update to any of the analytical members based on a change on the physical model. So if I come back into the 3D view, I'm just going to end this isolation here, and I want to make a change to my Girts. So I'll just go ahead and move the analytical automation here to the side a bit. And what I'm going to do is I'm just going to zoom in a bit here, and I'm going to change the orientation of my side Girts here. First of all, I'll just change this here into my wireframe. I'll select this member that we can see over here, so this side rail, and what I'm going to do is that I'm going to change the cross-section rotation to 0. There we go. And now I'm going to give it a Z offset value of 100. Give it a Z offset value of 100, and I will give it a Y offset value of -40. So that's exactly where I want it to be placed. So I'm going to do the same thing as well for the other side rows. So I'll make a selection of them like that. Hold down the Control key and make sure that I can select all of them. So hold down the Control key, make a selection, then hold down the Control key, make a selection over those. Change this to -40. There we go. And I will change this here, Z offset here to 100. And I will change the cross section rotation back here to 0. There we go. Alright, so you can see that they are connected properly. Then I'll go over here and do the same thing on this side. I'll make a selection over this, just scroll up. There we go, and just make sure that I have structural framings. In this case here, I'm just going to set the cross section rotation here to 180 degrees since it's in the other direction. There we go. I'll set the Y offset value here to -40 and the Z offset value here to -100. Then click apply. Alright, great. Now we've made a change to the physical Girts, but we haven't updated the analytical. So if I select one of the analytical, we can see here that the cross-section rotation is 90. But if I go to the 3D view and I select that same Girt here, let me just highlight the association so you can see it's this. Let me quickly change this here back to shaded. There we go. You can see here the cross-section rotation is 0. But instead of updating it, what I'm going to do is I'm going to go ahead and send this analytical model into Robot Structural Analysis Professional, since that is the design software I'll be using. I want to see how it looks like in robots before adjusting. So let's send the model into robots. To send the model to robots, the first thing we need to do is we need to make sure that we have load cases already defined within our Revit model. To do that, we come to the Analyze tab. Under Structural Analytical Model, we want to click on Load Cases and Combination. Based on the templates I chose to actually model the portal frame, we can see it comes with a list of load cases over here. And you can see their designated natures as well. So once I've confirmed I have load cases, I can just go ahead and cancel this. And now I can send it to robots. So to do that, I'll come over here into Robot Structural Analysis and I'll click on Robot Structural Analysis link. I'm going to be sending this model into robot and it's going to be through a direct integration. Under send options, you want to make sure that the self weight is assigned to the dead load case and you click OK. And over here we click OK to send it. You can see the status here as it sends all the members and nodes into robots. Once it is done, it will show me here a status. If I want to see any events, I can just click on yes to check, and I just have my messages for the imports from Revit to robots. And when I'm satisfied with this, I can cancel this and it takes me into robots and it shows me my model here respectively. So inside robots here, I can also close the Analytical Automation tool by now. I can just go ahead and orbit around the same way in Revit, holding down the Shift key and the middle scroll button to orbit. And I want to see if my members are placed in the right plane. So we can see here that even though we didn't adjust the analytical elements for the Girts, they are placed exactly in the plane that they are meant to be. But we just need to add an offset so they stay exactly on the side of the column. But we do have a problem here with our Purlins. As you can see here, they don't have that same slope that we assigned earlier on in the project. So let's see how we can fix that. Now I'm going to go over here to one of the Girts as a sample. Also I'll click on it. And under the gamma, I'm going to go ahead and expand this. I'm going to give it a gamma of 15, which is the same slope as our rafter. There we go. Now press enter. So you can see it slopes in the wrong direction, so it should be -15 actually, or 165. So let's try 165, and now you can see it is in the right direction. If we put -15 actually, it's going to show the other direction, but we have our connection facing here, so 165 is fine. So let's just switch it here to 165. Great. So we're going to do the same thing as well for all the Purlins in this direction. So to select them, I'm just going to click here on the top view. So I have a better view. So I'll hold down the Control key to select the elements. Then I can make a selection while holding down the Control key. You want to make sure that you're as patient as possible because you want to be having all the elements in the right geometry as much as possible. There we go. So I have all those elements selected. So for those, I'm going to set the value here to 165 and I'll press enter. So everything has been adjusted at the same time. So I'll come to this side here. Let's select one of the Purlins here. And you can see here is having a gamma of -15. So I'm just going to change this here. Let's say, let's go ahead and use 15 instead. So put 15. So you see 15 is in this direction. So what I'll do is I'll come here and switch here to the top view and then make a selection of all the Purlins here and adjust that also. Okay, so I'll set this here to 15. There we go. Let's orbit around and see if we are right. Great, so this is exactly what we want to achieve. Now we can send this update back into Revit. Let's see how we can do that. Now back inside Revit here, you can see the original elements here. This has a cross-section rotation of 0, while this element here have a cross-section rotation of 15. They might be 0 as well, depending on how you modeled your elements. And what I will do now is that I'll come back into the structural analysis toolkit, and I'm going to come and click on this button to update the model while Robot Structural Analysis Professional is still open. So it will bring in the recent updates from. Once it is done, it will show you the dialog box for completion. If you want to see the report, you can click yes to see the messages. So all of these are just transfer messages. So just click on close. If I select one of the members now, we can see here this is -165, so it translated it differently. Whereas for instance here, this is -15. So this is how Revit and robots are communicating. Let's jump back into robots. Back in robots, I'm going to go ahead and model or create the support conditions. It's much longer to do in Revit and it's faster to do in robots, so we'll do it here. So what we'll do is that we're going to be adding support conditions to the bottom of our stub columns. So what I'll do is that I'll come here and click on the front view, and I'll go ahead and make a selection over all the nodes for the stub columns. You can see here the node count has been, or node selection has been made here. Now I'll come over here under supports and I'll assume everything to be fixed for this example. Under nodal, I'll go here and click on fixed, and you can see the current selection is here. If I click on apply, you can see automatically the support conditions have been added to the stub columns. Now back inside Revit, we can come back and click on the Robot Structure Analysis Toolkit, and then we're going to click on Update Model again. If we click OK, we can bring those support conditions back into Revit. Once it's done, it brings up the dialog box if you want to see the event reports. So I'll click on No. And if you zoom in closely, you can see the fixed support conditions have been placed on our analytical model. Now, back into robots, let's learn how to create offsets. If I zoom in over here to where we have our girts, we can see they are placed exactly along the neutral plane on the column. So this is not exactly where they are meant to be placed. So they should be placed at the face here where we have the flange. So what we will do is that we're going to create special attributes called objects in robots. So to do that, I can come over here to geometry. Under additional attributes, you'll see this option called offsets. I'll create a new offset by clicking on this button here. And for this new offset here, I'm going to give it a value of about 275 mm. So I'll call this minus 275. I'll explain shortly. So this particular column here is about 450 mm in thickness or depth, right? So what we want to do is that we want to go ahead and divide that by 2, and then we'll add half of the total depth of this purlin, which is 50. So the full depth is 100, so with 50 to give us our total offsets, right? And I'm putting it as minus in respect to the global axis. So where are we going? So you can see your UCS icon here. So this is the positive X direction. So we want to move in the negative X direction. So under UX here, I'm going to put a value of minus 275. And then over here as well, I'll put here minus 275. Minus 275, that's about half of 450. That's 225 plus 50, which gives us 275. So I'll go ahead and add. Likewise as well, I'm also going to add a positive for the girts in the other direction. So I'll set this here to be positive, and then I'll go ahead and add them. I'll close this. All right. Now let's go ahead and apply the offset. So I'll come and click inside current selection. I'll select the negative one, and then I'll click on this here. So that is member 169. If I click on apply, you can see it has created that offset for this member. Now let's do that for multiple members at once. So I'll just come back here into current selection, and I don't want to click on the left view because I might select the other girts in the other direction. So I'll hold down the control key and then select them in a plane where I can select them multiple times all at once. There we go. So we want to make sure you don't miss any. Alright, it requires a lot of patience. So if I come back here and I click on apply, you can see we've applied our offset to those girts. I'm going to orbit in the other direction and do the same thing here. I'll click inside current selection. This time around, I'll change it to positive 275, then make a selection over the girts. There we go. And now go ahead and apply those offsets as well. Now we're going to do the same thing as well for our purlins. So our purlins here, the rafters go about 460 in total depth. So if you divide that 460 divided by 2, that's 230 plus this, half of this, that is about 50. This is 100 in full depth, so that's 50. So we have 230 plus 50, giving us 280. So we need to create an offset for this one as well. So in this case, the offset will be towards the positive Z direction since they are going upwards. So I come back here into geometry, additional attributes, then click on offsets. There we go. And then I can just borrow one of this. So I'll just double click on this here. I can change this here to positive. Let's call this 280. There we go. And we're going in this direction. So I'll turn these values here back to 0. Then I'll call this 280, 280. All right, then I'll add, okay, this meant to be 280, not 285. And then I'll go ahead and add this, then close. Now inside current selection, I'll just click on the top view, and I want to make a selection of all my purlins. So I'll just come here and just make a selection like this. There we go. Now I could as well just right click and then click on select similar by cross section. But the reason why I don't want to do that is because we're using similar section properties for the girts as well. So we'll see how to deselect those elements. So it requires a lot of patience. There we go. So after selecting all the Purlins, we have the current selection here. I'll select the 280 and then click on apply. And there we go. So we can see all our Purlins are now sitting directly on top of our rafter. Now I'm going to go ahead and create an offset for my braces as well, as they will be expected to sit very close to the bay area of the rafters. So I'll come inside my offset here and I'll borrow this positive 280 here, double click on it, and let's use an offset of 100 mm. So that's going in the positive Z direction. So I put 100 here and I put 100 here as well. Then I go ahead and add this, then I close. So let me come and click inside current selection. So I'll select one of the braced elements. If I click on apply, you can see here that it will now be offset up from its original direction, and it's much closer. Let me just select this and move it around to the bay area of the beam. So I'll do the same thing as well for all my other braced elements as well. So just go ahead and make a selection over them. There we go. Great. So just click on the top view. See them much better. Great. So after that selection, you can just go ahead and click on apply, and you can see all of them have been given an offset. Let's go ahead and model claddings. So the claddings will be used to distribute loads to the structure. To do that, first of all, I'll go ahead and turn off the section shapes, and you'll see here that the offsets are still visible. So for the purpose of modeling, I'm going to turn off the offsets. So to do that, I'll come here to the view. If I click on display, you see under favorites here, we can just temporarily turn off the offset. It's not deleting it, it's just going to go and hide them in view. All right. So to model the claddings, what we do is that we can come over here into geometry, and under geometry, you're going to see the option here for claddings. We're going to set our cladding here to be a two-way, set it here to contour or rectangular, whichever one works best for you. So I'll set it to contour. And I'll come to the intersection here at the apex of the rafters. So I'll select here first. Then I'll move over here to this point, and you want to make sure that you are selecting the intersection between the rafter and the brace, and not the other brace, that's the vertical brace. So select this one here. And then we're going to move all the way down, all the way to this other node here. Then we'll move all the way to the top. And then order this intersection at the apex of the rafters. Then I'll click here again to place my clad. There we go. So keep in mind that this is an auxiliary object and not an actual object that has properties in within robots. So we'll do the same thing as well in this direction. Move all the way down here. I want to make sure we're selecting the right nodes. So over here. There we go. Move down here. There we go. Then we're going to come here and then click here again to place the cladding. Now let's place the claddings at the side of the building. So I'm going to zoom in a bit here, then select this intersection, zoom out, and then I want to make sure that I come to the intersection of this column and the stub column. So this one here. There we go. We'll do the same thing as well in this direction. Click here, then come back here to the top, and then click here, then click here again. I'll orbit around, and then we place the other one in this direction. So I'm going to zoom in here, select this point, there we go, select this point, there we go, and I'll select, just make sure that that's the node, there we go, and I'll zoom in here, select this point, and click again to place my cladding. Alright, so once we're done, we can close this, and if we select one of the cladded elements, you can clearly see here that this is an auxiliary object in within robots. Let's apply simple planar loads to the structure. To do that, I'll go ahead and switch to a load case. So I'll assume this here to be dead loads. Then I'll come over here under loads, then click on load definition. I'll switch here to a surface load, then I'll click here on uniformly planar load. I'm going to be setting it with respect to the global axis, and I'll use here -2. So that's going to be -2 kPa, and then go ahead and click on add. Then I'll select the object I want to apply it to. So I'll hold down the control key, select this panel, and then I'll select this panel. So I'll click on apply, and you can see here that the load has been applied in this on these two cladding. So I also want to apply a load on one of the clads in this direction. So it's simulating in a way that it's going to sway in either of the directions. So in this case, I'll be going towards the positive Z direction. So I'll click on the planar load again. So I'll change the value here from -2, and I'll put here 2. I'll go ahead and click on add. I'll remove the elements that are here, and then I'll go ahead and select this clad here, and then I'll click on apply, and now you can see the load has been applied. If you want to look at the load labels, you can come over here and turn on the load value description, and you can see the magnitude. Now I want to analyze the structure. Before I do that, let's go ahead and pick a code combination from robots. To do that, I'll come to tools and click on job preferences. If I go over here to design codes and expand this, if I click on loads, I can see the code combination I'm using. If you click on the 3 dots icon, you can see the factors that are going to be used for each of the individual load effects or load cases. And if you want to choose a different code combination, you can click on the drop down and select from here. So I'll just cancel this. So I'm using the Eurocode notes for this example. I am going to go over here into loads, and I'll click on automatic combinations. So I'll leave it to the software to create my combinations for me. I'm going to be using the simplified automatic combinations. If I click on more, you can see the list of the combinations it's going to create for me. So it's going to have the ULS, that's the ultimate limit states, service limit states, accidental, and fire. I'll leave everything as it is. So I'll just click here to go back and make sure simplified automatic combinations is selected and click OK. Now, once I go ahead and calculate my model, I'll be able to see the combinations here. So let's go ahead and calculate. Alright, so the calculation is done, and I have 2 warnings here. So let me just go ahead and filter it. So one here is telling me that some of the objects don't have an assigned thickness. That makes sense because this is an auxiliary object. That's fine. And then some elements are not assigned to any storage. So we can also ignore this as well. That's for our bracing, our purlins, and our rafter elements. So that doesn't really affect our design. So I'll close the calculation messages. Now, after the calculation, if I come back here, if I click on the drop down, we can now see the list of combinations that have been created in the project. If I switch it, for instance, here into ULS, it's going to go ahead and show me the factored load combinations. Now, I can go ahead and interrogate my model. The first thing I want to do to simplify is to turn off the load symbols. So I'll just click on it twice to turn it off. And I like to quickly see the displacement of the structure based on the loads I've applied. So to do that, I can just come over here to the bottom and then click on displacement. So that's displacement or deformation. This way I can see how the structure is displacing under the loads applied to it. And we can see here that I have a maximum displacement of about 369.2. But we're looking at this under the ULS case. So I'm going to switch this here to the SLS, which is mostly used for deflection checks. So we see here we have a maximum deflection of about 273.5. I also want to look at my structure properly to be sure that it's actually deflecting accurately. So we can see our columns are deflecting, our rafters are deflecting as well. But we can clearly see here that the columns in this direction are not deflecting. So the reason for that is because we only applied loads in this direction, if you remember correctly. So we would use these particular columns, for instance, as the basis of our design. If we want to look at the analysis results on the members, we can come over here and click on results. If I come to diagram for members, under NTM here, I can go ahead and turn on my moment to check the bending moment. I'll come here to parameters, I'll turn on my text, differentiated and filled, so I can see the results much better. If I click on apply, I can see the moments generated on both the columns, some of the braces and the rafters as well. And you can see by looking at it, it's behaving exactly how you expect it to behave. We can also determine as well some of the members that are also in compression and tension. If we come here to NTM, if I turn off the MY, if I turn on FZ for instance, or FX for instance, and click on apply, we can also see the members that are in compression and tension. Keep in mind that you want to be checking these results with respect to the respective load combination. So for instance, axial force bending moment, you want to be using ULS, so you can see the values are much bigger or higher. Now I want to check the exact deformation on the members. So I'll turn off my axial force here. And then if I come into deformation, I can turn on the exact deformation for members. If I click on apply, I can see that from the structure. So I want to switch here to ULS, and that should be the governing code combination to use for deflection checks. And I'll just orbit around by putting down the shift and middle scroll button. And we can see the displacement, the maximum displacements are coming from our rafters, as you can see over here. All right. So once we've interrogated our model, we are good to go. I'm going to go ahead and create two manual combinations. The reason for this is that Revit may not be able to understand some of the combinations generated by robots. So I'm going to come over here into loads, click on manual combinations, and under the combination type, I'll set it here to ULS. I'll leave the combination name as 1, and then I'll go over here under parameters, and then make sure it's set to the nature of structural. I'll click OK. All right. So we have here the load cases. For DL1, I'll change the factor here to 1.35, and I'll go ahead and include it. For LL1, I'll set this factor here to 1.5, and I'll include this. All right. And then I'm going to go ahead and create a new combination. So do you want to save the defined combination? Click yes. So this new combination, I'm going to be using an SLS quasi-permanent combination type that's more specific to my code. So I'm just going to come to parameters. I'm going to change the sub nature here to category A and click OK. I'll click OK here. For the dead load here, I'll set the factor here to 1. I'll go over here, select this and include this. Select the live load and include this as well. I'll click apply to save it, and then I can close. You can see here that by adding load combinations, it does not invalidate your results, and you can now see them listed under here. Back inside Revit, we're going to import our model updates and our analysis results. So still under the Analyze tab, I'm going to come over here into Robot Structure Analysis Toolkit, click on the analysis link, and I'll click on Update Model and Results. I'll leave all the other settings as default. If I click OK, you can see it allows me to bring in the analysis results package as well as my required reinforcement results package. In this case, we haven't done that, so I'll exclude this. So I can also put in information about the model, the analysis name, and some of the information about the package. I'll go ahead and click OK, and it's going to import the results from robots. So here you can see that the integration with robot structure analysis is complete. Do I want to see any events reports? I'll just click on yes to check. So these are just transfer results messages, so it's fine. There we go. So we can go ahead and check some things. So first of all, under the Analyze tab, under Structure Analytical Model, you just click on this drop down. If I click on Load Cases and Combinations, you'll be able to see the list of some of the load combinations that were generated by robots as well as your manual combinations. So you can see that here, over here. All right. So let's close this. Likewise as well, under the Structure Analysis Toolkit, we can go ahead and look at the Results Manager. We can see exactly when that was done. You can see if it is up to date as well and the size that it is inside the project. If we want to explore the results, what we can do is we can click on Explore, and we'll be able to see the related results based on that analytical model. So first of all, I'll just close the results manager. I'll open this one up here, and I can choose between the load cases and combinations. So let's use the combination one, which is my ULS, for instance. If I want to see the results on the members, let's say depending moment, I can come inside here for results for members. I can expand the let's go to moments rather. I can go ahead and expand the moments. If I turn on my MY, if I click on apply, I will be able to see the bending moments within Revit, and you can see the results as well. If you want to change the unit of what you are looking at, so currently what I'm saying is in kilonewton meter, it normally comes with a legend as well. So you can see that we have the legend over here showing you the maximum and the minimum bending moment in within your view, as you can see clearly here. If I want to see, for instance, in a different unit, I can expand this here and I can change it to a different unit. I can also change the scale of what I'm looking at, my results as well. Let's just go ahead and close this. If I want to see, for instance, my reaction force at the columns, I can come over here to reactions. We have here under forces. If I expand this, if I turn on my FZ, for instance, and I click on apply, because we have support, we'll be able to see the reaction forces on all the columns or the stub columns. So this is a very useful feature and an integration between robots and Revit, which enables you to see the results in real time. I can as well check the axial force distribution as well, so that falls under results on members. If I go ahead and open up forces and I turn on my effects, I'll turn on my reaction forces here. And you can collapse it so you don't get confused with what you're looking at. So we're on results for members under forces for effects. If I click on apply, for instance, you can see the axial force distribution on the members as well as the members in compression and tension. Let's go ahead and look at the deformation pattern. So I'll just go ahead and turn off my results for members. I'll just collapse it like this. Then I'll switch my load case here or combination to combination 2, which is for my ULS. I'll turn on my deformation, and if I click on apply, I'll be able to see the deformation pattern of the structure. Another great feature of the integration is that you can go ahead and see the results in connections. So if I, for instance, close this, and let me open up the 3D view where we can see the physical elements. I'll go ahead and hide the analytical model for now. There we go. So for instance, where we have the intersection between this column and this top column, we have this connection. So if I select it, for instance, and I just click on override by instance, I've already done that ahead of time. If I click on edit, if you go to properties over here and go and click on code checking, just switch here to Eurocode 2 or the code you want to use. In this case here, if I click on use load combinations and click on forces, you can see all the combinations that come all the way from robot structure analysis. And this is useful because you can go ahead and send these results to another software and it will use these results for the design of that connection. I can also precise the elements based on the current configuration used to model the connection. So if I use EC3 for instance, and I use the combinations here, if I click on check, it should give me reports on if this particular connection I used works with the loads that, or rather the nodal loads that are on the connection. You can also have an HTML report here, which you can see basically the conditions used for the design of that connection. There you have it. That's how we model an analytical model for a portal frame structure in Revit. If you enjoyed this video, feel free to share with a friend, like and subscribe for more videos. See you in the next one.